It is time to learn the best method for solving quadratics because it is the most versatile of all of them. You know, most people, they know the quadratic formula, and that's what they kind of default to, and that's what it is. It's a good tool in high school, but the most versatile method is complete the square. And I've been thinking about how I'm going to do next year, and I'm going to push this skill a lot harder. I'm going to try to create a very, very good group of students on things like this. In years past, when I've taught complete the square, students have kind of shifted over to doing that as opposed to quadratic formula. And I'm just thinking about how I want to teach next year. And I think I'm going to push a lot of procedure the first 6 weeks, and then I'm going to focus more on concepts. I could make my job really easy and quit trying to reinvent the wheel every year, but I choose not to. I'm always looking to craft my trade to some degree. All right, so here is a quadratic. I know it's quadratic because it's got a square. And I'm going to do the complete the square technique, and this is how I teach it. We're going to move the constant to the right-hand side. So we're going to add 91 to both sides. R squared minus 4R is 7 plus 91, which is 98. And let me leave a little space here. I'm leaving a little space here because I'm thinking about step 3. Now, step 2 is to divide all terms by a. A is this understood one here. Now, the reason I'm talking about this, maybe you're not sure, all quadratics are written in the form of ax squared plus bx plus c. And this one is going to be equal to a 0. So a is the understood one in front of r squared. We're using a different letter here than x, but that's fine. I'm not going to divide everything by 1 because it doesn't change anything. I'm at step 3, which is find b over 2. Now the b term, it always gets some kids. It's kind of a consequence of how we teach things. We promote you all before you're ready. The b term is negative 4. So b over 2 would be a negative 4 over 2, which is a negative 2. That's finding b over 2. Now it says square it. If we take a negative 2 and we square it, we get a positive 4 because a negative times a negative is positive, and add that to both sides. So we're going to add 4 here, and we're going to add 4 here. And here's why I really like the complete the square technique, just because of factoring. The left-hand side is always what you call a perfect square. The left-hand side, if we just go with the old school guess and check technique, it takes an r and an r. Factors of 4 would be 2 and 2. And to add to a negative 4, they'd both be negative. And that's going to equal, by the way, 102. It's not going to be a pretty looking answer. Now, r minus 2 times r minus 2 is something times itself, which means that it is something that has been squared. And this is called a perfect square because of how it factored. It factors a perfect square. We are now moving on down to step 5, which is to counteract squaring, and the opposite of square rooting is to take the square root of both sides. Because if we take the square root of the left-hand side, we have to take the square root of the right-hand side. And pay attention to exponents. That was a 2. That means there were 2 solutions there. So we include what we call the plus or minus symbol. Now, the square root annihilates the square, giving us r minus 2. And that'd be plus or minus the root of 102. And I'm just running through my head real quick to see if this simplifies. It should. It's 2 times 51. 51 is 3 times 17. Well, it does not. No, it's 6 and 17. There's not much you can do with that. So it's just going to stay plus or minus the root of 102. Now, the last step here is to isolate x, which in this case is the variable r. And all we have to do is we have to move that 2 to the right-hand side. We're going to put it before the plus or minus symbol. And this one gave us 2 kind of funny-looking answers, which is another thing that bothers kids about upper-level math, is we don't really use decimal approximations too much. But r is 2 plus the root of 102. That's like 2 plus 10 and some change, 12 and some change. Or 2 minus 10 and some change, which is like negative 8. It'd actually be negative 7.99, something like that. But that's the complete the square technique on that one. And it's not a bad technique. And most people, including myself, have a tendency to push the quadratic formula, and I need to get away from that. I do, because I saw the consequence of that this year with my pre-calc class, of getting away from completing the square. And I know a lot of teachers don't like to teach to complete the square because, quite honestly, kids are kind of bad at it. But I found in years past that kids that complete the square the quadratic formula comes so much easier to them. I think they just appreciate the quadratic formula because of it. So I'm going to be spending more time completing the square this next coming year, and hopefully years past than I have recently, because I think it'll make things better. If you teach something hard, it's easier for people to do something easy. All right, here's our next one. It's 6x squared minus 48, and that is equal to a negative 12x. Now, compare and contrast this to what we call standard form up top. It's not in standard form, okay? Standard form, which I like to call STD form, would be 6x squared plus 12x minus 48. And then it would equal to 0. You shift things around. You know, if we jump equality, we change our signs, right? So let's move the constant to the right-hand side. The constant here is 48. It needs to get moved over. We'll have 6x squared plus 12x remaining on the left-hand side. We're at step 2, divide all terms by a. Everything gets divided by 6, and this one's nice in the fact that everything is divisible by 6. We'll have x squared plus twice x, we'll leave a little space, equal to 8. The reason I'm leaving space is obviously because I've done this a few thousand times. I am now at step 3. I'm supposed to find half of b, and again, that's b. b is 2. b is not 2x. Don't be that kid. Don't be that kid. b is just 2. b is the number or the constant coefficient in front of the singular x. We're supposed to find b over 2. Well, that would be a 2 over a 2, which is a 1. And it says square it. So we're going to square that 1, and we're still going to get 1, because 1 times 1 is still 1. And we add that to both sides. Now, what's cool is how this factors, okay? It factors as perfect square. It's going to factor as x plus something squared. And that plus something is always the b over 2 term. 1. X plus 1 squared equals 9. This one's a lot easier than the last one I did. A whole lot easier. It looked harder in the beginning, but it's not. Now, the opposite of a squaring operation is to take the square root of both sides. The exponent there says there's 2 solutions. That's why we include the plus or minus symbol. The square root of 9 is 3, but in the context of this problem, because there were 2 answers, it's plus or minus 3. And the square root cancels out the square, leaves us with x plus 1 is equal to plus or minus 3. Next move, really simple move that 1 over. And, you know, I've been a teacher for a long time. When I first got into this field, I thought, you know, like everybody could do that. Everybody could do negative 1 plus or minus 3. And they can't. Like, it's disturbing. Like, fix that issue. This is telling you that x is a negative 1 plus a 3, or x is a negative 1 minus a 3. Of course, I was under the idea when I first got into education that kids could add and subtract, and it's just not the way it is, apparently. But negative 1 plus 3 is going to be a 2, and a negative 1 minus 3 is a negative 4. There you go. It's not too bad. I got one more for you, and it's kind of ugly because I know it's going to introduce some fractions. That's where, to me, they finally get a little interesting, because we get to go back and think about all the skills we learned in 4th and 5th grade math, which you could do at one point in time. Problem is we gave you calculators, and you quit using that brain of yours. You were given a brain. Use the brain. So, let's do the one that's got fractions. The fun one, because fractions make things fun. Pretty much every word that starts with an F is fun. I'm sure there's some exceptions to that rule. Maybe you can think of 1 or 2 in your head that are not fun, but I guarantee you if you sit around and think about words that start with an F, they're fun. All right, last one. 7k squared minus 16k plus 100 is equal to 0. Now this one is in perfect standard form. So we're going to do steps 1 and 2, and steps 1 and 2 can be done out of order. It doesn't really matter how you do it. We're going to move that 100 over. That'll give us 7k squared. I don't know why I have a mixture of k's and x's. Autopilot, I guess. All right, there's that move. We are now at step 2, which is to divide all terms and any terms you see by a. And a happens to be 7. So we're going to divide that 7 out. And if we do it to one thing, we do it to all of them. And you can see this one's going to get kind of bad looking, right? It's already got fractions. And the hard part here is going to be finding this b over 2 term and squaring it. Leave a little space here. Now, b is negative 16 over 7. To take half of a number, you introduce a 2 in the denominator. So look how I'm writing this. I'm writing b over 2. I have introduced a 2 in the denominator. For equality purposes, I'm going to introduce a 2 in the denominator on the right. That just makes sense, doesn't it? And this would be negative 16/14, which will reduce. And that's how this stuff works. You could also think about the negative 16 over 2 being negative 8. It reduces down to negative 8/7 because both pieces were divisible by 2. Again, that is b over 2. We're still at step 3. We're supposed to square this thing. So we're going to take our negative 8/7 and we're going to square it. And if you square an 8, 8 times 8 is 64. If you square a 7, you get 49. And that, boys and girls, it says add to both sides. So that gets added to both sides. So plus 64 49ths. I'm going to add it here as well. Now, when I teach high school math, the issue I have is that most kids don't remember 5th grade math. You know, how do I add those two things together? And this, by the way, this thing doesn't have any real answers. It's not a very pretty problem. But what I do is I have to seek a common denominator. And I know that 7 times 7 is 49. So I'm going to introduce a 7 in this guy's denominator. And if I introduce it to the denominator, I introduce it to the numerator. That's going to give me negative 700 over 49. And I'm going to add to that 64 49ths. And negative 700 plus 64 should be negative 636. So negative 636 49ths. Whew. Lots of fun stuff there. Now, that's what's going to be on the right-hand side. What's on the left-hand side? Step 4, factor the left-hand side as a perfect square using b over 2. So we're going to have a k, it's going to be squared. Okay, perfect square, it's going to be squared. Using b over 2. This was b over 2. Minus 8/7. There we go. And again, that equaled the sum of the right-hand side, which was negative 636 49ths. Now, the opposite of a squaring operation has always been a square root operation. And this video isn't specifically talking about things that are real or imaginary, it's just this problem happened to work out that way. My guess is if you have completed the square, you could be in Algebra 1. In Tennessee, you'd be in Algebra 2, and we're not supposed to officially talk about this stuff anymore. But the square root of a negative is imaginary. So I'm going to have the plus or minus 2. The imaginary square root of 636, which I'm going to have to reduce. I feel like I ought to know it off the top of my head, but I don't know. Over 7, because the square root of 49 is 7. And the square cancels out the square root, leaves me with k minus 8/7. And that equals plus or minus that guy. So 636, I know that it ends in a 36. It's probably divisible by 6, right? So I know that the square root of 636 would be 6 times 100 is 600. Would be the square root of 6 times the square root of 106. And I'm just going to keep working with these things, okay? 106 is even. That means it's divisible by 2. 6 is even. That means it's divisible by 2. I have a square root of 2 times the square root of 3 there. At 106, I have the square root of a 2 because 2 times 53. And these two pieces can be put together. That's going to give me the root 4. I can put these two pieces together. 3 times 53 is 159. This is one of the things kids do not like about Algebra 2 is radical simplification. So that ugly thing reduced down to 2 roots of 159. By the way, over a 7, because I still had a 7 there. We're going to add 8/7 to both sides, plus or minus the imaginary root. Let me put the 2 out front. It was imaginary. 2 imaginary roots of 159 over 7. And there's your 2 answers. These we don't tend to do much with. We could write them separately, which some people really enjoy doing. It's technically correct. Your 8/7 plus 2i roots of 159 over 7. Or it's 8/7 minus 2i roots of 159 over 7. I know some teachers are particular about that. Sometimes I am. Just because sometimes on a standardized test they make you fill in 2 blanks. And if you don't get kids accustomed to doing that, they forget that they can because you're kids and you're not that interested in math. It's just the honest truth. So, do a mixture of both with your students. And there you go. There's complete the square. Hope you enjoyed the video, by the way.